Recorded.
Good morning, Chris.
Good morning.
Morning, Dave. Okay, guys. Good morning and welcome. And before we get started, um, does anybody have any questions?
No.
No questions? So, okay. So what we'll be doing today is going over, yes, okay, the questions for chapter 3, whether that was at the end of the chapter or in the examination review, and we'll play a little around with the questions to try to make some of the other answers. Yes, okay, correct. It says, okay, option B could have been a right answer if the question had been worded in this way and so, okay. So let's see. Well, as far as the relations are concerned, as far as the general concepts about our cell parameters are concerned, you guys feel confident? Okay. So we are on page number 41. And we just, okay, I'm going to start with question number 1. Okay. No, yes, okay. Now, what are the units of? Okay. So you can say, it's okay, units of. And what we have first is wavelength. And that will be, yes, okay, millimeters. Yeah, okay. Mainly, yes, okay, if you remember, yes, okay. Use the unit millimeters. Okay, okay. But this number here can also be expressed with a unit of, for instance, yes, okay, micrometers. Okay, okay. Just keep in mind that then it's going to be, yes, okay, this many micrometers. Clear? Okay. It can also be expressed in terms of, yes, okay, using the unit centimeters. But then just keep in mind that, okay, it's going to be, yes, okay, 0.144 centimeters. Okay. The other one is going to be frequency. The actual unit for frequency is going to be hertz. Okay, it's going to be hertz. Now you're probably not going to see as, okay, a fraction of hertz. You're not going to see something that will say millihertz. Clear? Okay. Okay. but rather as okay multiples of hertz, which could be as okay things such as kilohertz, megahertz, and or for instance, okay, gigahertz. Okay. Just remember that okay, at this unit of hertz actually is okay was just a translation of what we could say as okay cycles per second. Okay. So if you say kilohertz, that's going to be as okay 1,000 cycles per second. Did that make sense? If you, for instance, said megahertz, that's going to be as okay. Okay. One million cycles per second. Like that. Okay. Intensity. Okay. Now we said an intensity is okay was power per area. Okay. Where you mean is okay, just translate the units watts per area that we could say is okay would be any unit of distance squared. Yeah, okay. Okay. Now, yes, okay, as far as watts are concerned, yes, okay, we can have fractions of a watt. For instance, okay, you may have, okay, it's what you can call a milliwatt, for instance, which is going to be, yes, okay, the thousandth of a watt. Yeah, okay. You can also have, okay, as multiples of a watt, for instance, yes, okay, kilowatts, which is going to be equal to, yes, okay, 1,000 watts. Okay. All dependent. Okay, likewise, okay, you can have, okay, any unit of distance. You can have a centimeter if you want to, yes, okay, you can say millimeters. Okay, you can go meters. Okay, you can go micrometers, you can go nanometers, you can go or cell. As long as, okay, it's a unit of distance being squared, it will become area. Did you guys get that?
Yeah.
Get speed or propagation speed, or even as okay, as you will see later on in a later chapter. Because that's okay, propagation speed. Okay, but that's okay. The word propagation has mean as okay just to because it's okay create confusion. Propagation speed and speed is the same thing. Okay, okay. So what we said was yesterday there was going to be as okay any unit of distance or unit of time. Yeah, okay. Now for the sound of speed, for instance, okay, speed of sound yesterday is okay. We said we could as okay express it as in millimeters per microsecond. Okay. But just keep in mind, guys, okay, it can also be, okay, be expressed as, okay, millimeters per second. Okay. You can also go meters per second. You can also go as, okay, meters per microsecond. Clear? Okay. But the thing that's going to happen is that, okay, as you change the units from, let's say, okay, millimeters to microsecond to millimeters to second, of course, yes, okay, the number is going to, yes, okay, change accordingly. Did you guys get that? Okay.
Yes.
Period. Now, some people also, okay, in the US, you call listing here period, right? A sentence, and then you have a period, right? Isn't that what you call a period?
Yep.
Good. Is that the correct term? No, what's the correct term? If period is not the correct term, then what is the correct term then?
Are you talking about in regards to time, or are you talking about in regards to punctuation?
Punctuation.
Okay.
Or what's the correct term for the punctuation then, if period is not the right term for that punctuation?
Same term, different meaning.
Okay. Well, okay, what comes at the end of a sentence? Yes, okay, what you guys call here is a period, right? Which is not the right name for it. You already agreed to that. So what is the correct name for a period as a punctuation?
Stop.
What kind of stop?
Full stop.
Full stop. That's what they call it all over the world. It's a full stop. Because, okay, you have a stop or a break when you have a comma, right? What's going to be the difference between comma and full stop? The full stop is okay in terms of numbers will indicate that, okay, this is the end of the whole number. Whatever you have after that full stop is a fraction. If I write as, okay, 1.5 or 1.5 or one full stop 5, what does that mean? One is the whole and point is, okay, full stop 5 will be 0.5, which is a half. Clear? Okay. Whereas if I wrote 1 comma 5, okay, I gotta add something else out of that 5. Okay. Yeah. Okay. So yes, okay, whatever you have at the end of a sentence is not a period. That's what we call a full stop. Now, what's going to be the period? Could anybody define what period was? And now we're not talking as an exclamation mark or punctuation.
The time it takes to complete a cycle.
The time to take complete a cycle, right? Okay. Okay. So I was going to just, okay, be measuring or represented by the unit of time. There are many, that's okay, one would be second. Clear, okay. But mainly, guys, because what you have seen or what you may have being able to just, okay, figure out is that in 1 second, yes, okay, we're going to have several thousands, if not millions, of cycles. Yeah, okay. Yep, okay. So that's why that's okay. It can be for yes, okay, milliseconds or microseconds. Did you guys get that? Okay. But still, generally, it's okay as long as it is represented by it's okay a unit of time. It should be good. Yeah. Last one is power. So what's going to be the unit of power? Is going to be Vito's elder brother, which is watts. Yeah, okay. Now again, as you say, it's okay, especially it's okay when we back here, it's okay, discussed intensity. I say yes, okay, well, okay, you can have multiples of watts. For instance, yes, okay. Megawatts. Okay, which we're having is okay. 1 megawatt is going to be 1 million watts. You can say 3 megawatts is going to be 3 megawatt or 3 million watts. Okay. You can have, okay, yes, kilos, which is going to be, yes, okay, just thousands. Okay. You can even, yes, okay, have fractions. Okay. Now, common one will be, yes, okay, a milli, which is going to be, yes, okay, 1/1000 of a watt. Okay. But they still all are, yes, okay, units of power because, yes, okay, what you still have is the watts. Okay, so here we can mainly say, it's okay, that, or okay, the kilo, kilo, mega, milli, nano, micro, whatsoever, these are mainly as okay, just prefixes. Yeah. Now, guys, question number 2. Now, here's okay, what it says is, does the medium or the source, or the sound source, sorry, determine these parameters? Okay, now the first one that we have was wavelength, and that was the only one that was determined by both. Yeah, okay. Source, okay, which was going to say, okay, be the transducer, and the medium, which was going to be, yes, okay, the tissues. Okay, whereas, okay, in the tissues, we can mainly say, okay, what's going to, okay, determine the wavelength in the tissues is mainly, as okay, due to the speed on the tissues, that's okay, that will lead to, that will determine that wavelength. Yeah, okay. Let us put it this way, as okay, had the sound been traveling at the same speed in all tissues, then your wavelength will only be determined by the transducer. Did that make sense? But mainly because in the tissues, that's okay, there's going to be, that's okay, different speeds. That different speed will cause different wavelengths in the medium. Did I make myself clear on that one? Okay, so it's different speed in the tissue that leads to different wavelengths in the tissues, but not vice versa. Did you guys get that?
Yep.
Frequency. Now what I was going to is okay, determine the frequency of the transducer of the sound wave. Well, okay, that's going to be the transducer. How and what not, says okay, those details will be discussed later on in I think it's chapter 10 or 8. Okay. What we mean is okay, we'll look at just okay the transducer and say it's okay, or at the transducer. I mean, it says okay, what characteristics is it that a transducer has that will determine its frequency. But for now, just remember this much that okay, as it is determined by your by the source, which for our case, yes, for now at least, is going to be the transducer. Now, guys, the next fellow here is intensity. Okay, now you may see that, okay, what it says along with intensity is the initial intensity. Yeah, okay. And my guys, that is going to be, it's okay, the source. Clear? Okay. It had could set, or it could have said power instead of intensity. And instead of said initially, that's okay, it would still have been source. It could even have said, let's say it's okay, amplitude with initial, it would still have been the source. Clear? Although it's okay, what is it that we mean by the source here? Is the ultrasound system. Is that clear?
Yep.
Okay. Now, guys, why did they wrote initial? Because what we said about all these three parameters here, whether that was the amplitude, whether that was the power, or whether that was the intensity, that okay, yes, they decrease as they propagate through the medium. Yeah, okay. So when they decrease, what's going to end at the end of the story, or end of the journey is that you would have okay as a final intensity. You could have said okay, you also had okay as a final power. Or as okay, you could say that you have had a final amplitude. Is that clear?
Yes.
Right, okay. Now this final amplitude here is also going to be, or intensity of power is going to just be determined by both. First, why both? Because the remaining be dependent upon your initial powers on intensity or amplitude. And likewise, the type of tissues that it passes through. Because it's going to be the nature of the tissue here that will cause a certain or specific degree of decrease in the free bigness parameters here. Did that make sense? So the final intensity is going to be determined by both. First, just what was your initial intensity or power or amplitude, which was determined by the source. And then after that, that's the media or the tissues and the medium through which the sound will pass. Each of those, or individual tissues are going to cause their own level of decrease in the three bigness parameters. Did you guys get that? So had it said final intensity, final amplitude, or final power, then the answer would have been both. Both what? Source and medium. Did you guys get that?
Yep.
Okay, I think there's a question later on when they ask this very same information at some point. Okay, but it's going to get more clear, yes, once we get to chapter 6. But just so you guys are aware. Propagation speed. Now, what determined the propagation speed?
Medium and source.
What determined the propagation speed of sound?
Just medium.
Medium.
It's just the medium, okay? Yeah, okay. We have already, yes, in the previous chapter, I told you, yes, gases and solids. Yesterday, it's they talked about metal, for instance. Okay, then we say it's it is slower in liquids. And we could say water. And likewise, yes, slowest in gas. And we could say it's air. So these are all features. All these here. All yes, characteristics of the sort of the medium. Yeah, okay. So no matter what the wavelength, no matter what the frequency, no matter what the power, intensity, or amplitude, and so on, so on, so. Okay, it was going to be as the nature of the medium that will determine the propagation speed. Okay. You mentioned those two last characteristics of the nature of the medium, which was the stiffness of the medium and yes, the density. And you has okay discussed their relationship to the propagation speed. Nextus, pectus, metextus. Period. Oh my God. Clear? Okay. So what was period? Wholly and solely as okay. The source alone. And what do you mean by the source here? That is going to be as okay the transducer. Okay. What was the period? The time that it takes to complete one cycle. So now you can say, okay, what's the period for me? The time that it takes me to draw one cycle. Okay. Once I find says, okay, maybe get a routine done it, just okay, I can be able to, okay, I can do it faster. Clear, okay. And the faster I am able to just, okay, draw each cycle, well, okay, the lower is it that, okay, yes, the period will get. Because I end up taking less time to draw a cycle. Now the next two ones, that's okay, power and amplitude. Now we already, that's okay, discussed them here. And the thing is, that's okay, that it says initial. So one is it says initial, that's okay, then it's going to be the source. And it said final, then it had been both. Did that make sense?
Yes.
Okay. Question number 3 now, listen guys. Using a particular ultrasound system and transducer, which of the following can not be changed by the operator? Yeah. Okay. Now the wavelength. Now what they mean is okay by cannot be changed by the operator. Means that, okay, yes, sorry. What that will mean is not adjustable. Now, is your wavelength adjustable? No, it's not. So it's not adjustable. So it cannot be changed or adjusted by the operator. Now, some of you may as okay want to rip off my head now, because the next one is frequency. Now, if you go back to the table, it says not adjustable. And so, yes, okay, that is wrong, right? But yes, okay, here, yes, okay, it is not adjustable. And some of you will say, but why? You said otherwise. Because what the question says is, okay, using a particular ultrasound system and transducer. So that's what makes it non-adjustable. Is that clear?
Yes.
Okay.
But can you give us like an example when we would put yes? So if it said, like, what would it have to say to put yes?
Now, most likely, my dear, it will say it's okay, a broadband transducer.
Okay.
Now, what a broadband transducer is, well, okay, that's going to be something that we talk about in chapter 8. But when I talked about it's okay, updated, or we can say, okay, yeah, updated transducer. That's mainly it's okay, what we mean by that.
Okay, so for now, should we just think?
Stay no.
Okay.
Unless the question doesn't read something like, okay, using a particular, if it doesn't say using a particular ultrasound system and transducer. Had you taken that phrase out of the question? Did that make sense?
Yeah, so like if it
Okay.
just
Then
read,
it would have been, yes. Then it would have been, yes, okay, adjustable.
okay,
Did that make sense, my dear?
yep,
But just because the question states using a particular ultrasound system and transducer, the answer for frequency is that, okay, yes, it is not adjustable. Did you get that, my dear?
yeah,
Okay. Now intensity. Is that adjustable? Yes, it is adjustable. What we mean by being adjustable? Changeable. How? That's okay. By the power output. That we say is okay, we can increase it or we can decrease it. Did you guys get that?
yep,
Good. Your propagation speed. That's not adjustable. You can't change it. Why? Because it's going to, yes, okay, be determined by the media. Okay. So anything which is wholly and solely as okay determined by the media is not adjustable. Yeah, okay. Not to talk about, yes, okay, they still talk of, okay, as using a particular system and, okay, but that's not the thing here. No matter what, even as, okay, even if you're taking that phrase out of the question, propagation speed was still not adjustable because it was wholly and solely determined by the medium. So is your period, with or without the initial part of the phrase here. Period is not adjustable. Okay. The only thing that you can do to, let's say, okay, change the period is to change the transducer. You use a different transducer then, which then will have, okay, as a different period. How and why and so on, so on, so. All things that is okay, we'll talk about again in chapter number 8. Yeah. Now the next one is going to be as okay, where we say power. Now, yes, okay, just the very same as, okay, as your intensity. Yes, okay, it is adjustable. Did you guys get that? How? Mainly it's okay by the same power output knob, which okay, yes, okay, could decrease the power of return clockwise, anti-clockwise, and increase the power of return clockwise. Did you guys get that?
Yes.
Yes.
Okay, guys. Now just look at this last one here, which says amplitude. Now what they just did here in amplitude was that they just, okay, just wrote initial. Is that clear? Is that clear, dear?
Yep.
Okay. Now, guys, the answer had been the same as, okay, had they even write initial for intensity, had even wrote, yes, okay, initial for power. It is adjustable. Because that's pretty much, okay, as what you do when you rotate on the power output knob. You're increasing or decreasing the initial power, which means that's okay, mean that you are increasing or decreasing the initial intensity, which means that you are increasing or decreasing the initial amplitude.
So then obviously if they wrote like final next to it, the answer would be no.
Who said that?
Caitlin.
Had it said final instead of initial? Of course, that's okay. Your answer had been no. Because, okay, of course, yes, okay, you're finally, yes, okay, maybe, yes, okay. 50% is going to be, okay, 50%. Partly, yes, okay, dependent upon or determined by the initial, which was, okay, yes, of course, yes, okay, were adjustable. But the remaining of, yes, okay, what happens before, yes, okay, you get the final was determined by the median, which you have no control upon. Did that make sense? Now, Caitlin, you just earned $1. So on the 21st, just remind me to give you $1, okay? So
Cool.
who wants to end up earning money now? Well, let's just strike a deal, guys. If somebody comes up with a clever answer like this, what can you get? You can get a bonus point that you can utilize in case you fail. Now, don't say, well, okay, I want to utilize my bonus point although you passed. No, keep that for the case when you fail. God forbid that doesn't happen. Now, it's okay. If at the end of the course you didn't fail a test and you had earned, let's say it's okay, 10 bonus points, you will get $1 for each bonus point. So all of you, yes, okay, what are you going to do with all that money that you may earn?
Free tuition.
Okay. Ah. Okay. I thought you could have used it for something else, but I guess I had false hopes. Okay.
Can we gift it to somebody in need of bonus
Yes.
points? Okay.
No, bonus points?
Oh,
No, don't do that.
well,
You
you
can
said
gift the
at the
money.
end of the.
You can gift the money to somebody in
Oh,
need.
okay.
Do you know anybody? Do you know anybody who you can gift that money to?
Yeah, a lot of
As
people
yes,
need money.
okay. I know somebody. You don't know him or her? You're a poor teacher. Just kidding, guys. Okay. But yes, okay. Caitlin, yes, okay. You have bonus point. Well, let
Thank
me
you.
just write that down. So Caitlin, 1 bonus point. Good. Okay, my dear. So Harrison final, then it had not been adjustable. Clear? For what? Your power, intensity, and amplitude. By initial, yes, okay, that is adjustable. Okay, guys. Next to questions. And what they mainly says, okay, here it is. that a wave with a frequency of 15,000 megahertz is ultrasonic. And that's true. Now, please keep in mind, guys, okay, this 15,000 megahertz, well, actually, it will be the same as, okay, 15 gigahertz. Okay. Now, right now, that's okay. Of course, that's okay. Both of these here are ultrasonic. Why? Because it's okay. It is greater than 20 kilohertz. Yeah, okay. Now, guys, had it said something like this, that, okay, yes, a sound wave of 15,000 megahertz is ultrasonic and can be used for diagnostic imaging, then, of course, it's okay, your question, the answer would have been false. Because what we mainly can say is, okay, that the maximum range of your frequency for ultrasound was 15 megahertz. There you can mainly says, okay, this, 15,000 megahertz here is actually is okay, 1,000 times greater than the upper maximum range. Did that make sense? Okay, but any frequency that was greater than 20,000 or 20 kilohertz will be ultrasonic. But this one here cannot be used for diagnostic imaging. Because in that case, okay, the maximum range was 15 megahertz. Did you guys get that?
Yeah.
Good. Question number 5. Now, what they say here that, okay, yes, that the amplitude of a sound wave, yes, okay, increases 3 times its original. Would that mean that the intensity increases 6 times the original?
No.
That's false. Clear? Okay. Now that's mainly because, okay, some people may not know as, okay, what the squaring mean here. Where the squaring mainly means that, okay, yes, this 3 times here is going to be multiplied by itself. So in this case, yes, okay, of course, when the amplitude increases, yes, okay, the intensity will increase, but it's not going to increase 6 times, but rather 9 times. Yeah. Did that make sense?
Yeah.
Okay. So any number being square main, yes, okay, just mean that it is being multiplied by itself. Okay, question 6 to 12, yes, okay. Answer is okay, used in the graph below. Now let me just see if I can somehow reproduce this graph here that they are given us. Now they say C B A or D. Now question number 6 asks about, okay, what does the letter A represent? So the answer that we have is amplitude, period, frequency, wavelength, and peak-to-peak amplitude. And A, guys, is going to represent the peak-to-peak amplitude. Okay, yes, okay, you say, okay, this here could have been A. So what I said was, okay, as this was from the peak of one wave to, yes, okay, to the peak of the other wave, or the trough. Okay. Did that make sense? Okay. So this here is, okay, that was the peak-to-peak amplitude, which were represented by the arrow E. Question number 7. And what the main is says, okay, which of the following best describes the line I defined by the letter B, which is this one here. Now that represent the amplitude? No. Okay, is that going to be the peak-to-peak amplitude? No. Clear? Okay, is that going to be the frequency? No. Is that going to be the wavelength? No. Or that's going to be none of the above. It represents nothing. Okay, so for B, nothing. Now, which of the following, yes, okay, best describes the line identified by the letter C? Now, amplitude, that's okay. Says okay, this is okay, that would have been the amplitude. So letter C is amplitude. Okay, it's not going to be peak-to-peak amplitude because that was line E. Okay, it's not going to be frequency either. It's not going to be wavelength. And then it says, okay, none of the above. So C here is, okay, was going to be represented by amplitude. Clear? Okay. Did you guys get that?
Yeah, just like a clarifying question, I guess. So if we were to have like something like this on the quiz or like the big test at the end, if it wanted a question, like if the answer were to have been like frequency, would it have had to say that this was in 1 second? Or, yeah,
It should.
okay.
It should.
So like for this, like obviously it doesn't say that, so
No.
we can kind of assume that like frequency or
Common sense, exactly.
okay. Thank you.
Unless, okay, that would have been, let's say it's okay. Let's say that you have something like this, right? Okay. Then you could say it's okay, and that says okay. That's in Q. That okay. That could have been frequency. Right, okay, which will have is okay, the whole thing.
Okay.
Right, okay.
Yeah, that makes sense.
Good. Question 9. So which of the lines about A, B, C, D is most likely going to be as okay, the reciprocal of frequency? Now what they're asking you here is which of the following lines here is going to be reciprocal to frequency? Now what did it mean? What was it that was going to be reciprocal to frequency? What was reciprocal to the frequency?
Period.
Period. Yeah, okay. And what you mean it says okay, so what was going to be is okay, what will be of all these lines, whether you said A, whether you said B, whether you said C, or whether you said D.
D.
D. Because you can make it says okay, it goes from it's okay, the beginning of one cycle, or you can say it's okay, to another. Clear, okay. All those okay. Or you can say it's okay, identical points on a cycle to an identical point on the following cycle. That's going to be it's okay, the period. Clear, okay. In this diagram here. Okay, but the tricky way that they ask is okay, which of the following here is reciprocal to frequency? Did you guys get that?
Yep.
Good. Now the same question is okay, where they mean it's okay, still ask about Mr. D. Which of the following best describe the line identified by the letter D? So again, it's okay, they go D. Now they say amplitude. Now amplitude, that was C as in cat. Peak to peak amplitude, that was A. Frequency is okay, we can't. Okay. Here they say it's okay, wavelength, and then they say none of the above. Now D mainly is okay because it marks what was the period. It's also going to be as okay wavelength. Because we said was okay, the period and wavelength are the same as okay, distance or a component of wave or so on, so on, so measured. The only thing that was different between the two was the period measured the same thing in time using a unit of time, where wavelengths, okay, measure the same thing in terms of distance. Did you guys get that?
Yep.
Good. Question 11. Now, which of the following best describes the line identified by letter D? I guess, okay, they are stuck at D. Okay, so what do they have? Amplitude, peak to peak amplitude, frequency, period, and none of the above. Here they made us, okay, just repeated question number 9. Okay. Okay, then question number 9 to me is okay, well, a little bit tricky and says, okay, what was the reciprocal of which line represented, or is it reciprocal to frequency? Okay, which was D. Yeah, they are directly, yes, okay. Say, well, okay, these are the options. Do you find period in any of them? Which was okay, yes. Borrow had identified line D. Is that clear?
Yep.
Okay. Okay, now which of the four, okay, which of the lines above is most likely to be determined by the source and the medium? A, B, and C. So let's talk about, okay, line A, they're talking about line B, and they're talking about line C. Now, I don't know why they wrote B, because B was nothing. This would have been the answer, because D, we say is okay. At least it's okay. One thing that represented was the wavelength.
It says in here that B is actually 2 wavelengths. It specifically says line B is actually 2 wavelengths.
Mhm.
Okay.
But that's not your wavelength. Clear? B is not your wavelength. That would have been the same as saying that 2 is equal to 1. If I say how many fingers? How many fingers?
2.
2. Good. How many fingers?
1.
1. Okay. And if I say, well, okay, as what is determined by both source and medium is 1 finger, not 2 fingers. Because this was 1 wavelength, right? Okay. So that's how I look at it.
So that was question 12.
That was 12.
So the book is wrong.
If you call this 1 finger, then yes, okay, it's wrong. Because, okay, my dear, then where goes the limit? How many fingers?
5.
Okay, but like, okay. Then it goes, okay, line 2 as we label, yes, okay, or 5 fingers. This is going to be, okay, the length of 5 cycles, right? Not 1 cycle. Did that make sense? Clear? Okay, now what they asked is, okay, what is going, which of the following lines is determined by both source and medium, which was what is determined about both source and medium?
Wavelength.
Wavelength. Which is going to be length of
One
How do
second.
we define wavelength? The distance or length of one wave, right? Okay, not 2 waves, not 5 waves, not 7 waves, but just uno.
So the answer would be D, not B, which the book
Yeah,
gave.
yeah.
Okay, just wanted to make sure.
Okay, guys. Unlucky number. Should we skip that one? No. Now, why does that unlucky number has to fall on a Friday? And what if it happens to be it's okay in the month of April? Isn't that what they say that is the super unlucky one? April 13th?
Maybe.
Okay. Yes, okay. A dozen of days after, yes, okay, you are fooled. Okay, clear. Okay, question 13. Lucky or unlucky, April or December, Friday or not, we answer in the question, okay? So true or false? Now, if the power of a wave is halved, now, guy, when you say that it's halved, it's going to, as okay, we can say it's reduced to half, right? Okay. Okay. The intensity reduced to 1/4 of the original value. Is that going to reduce to 1/4? That's false. Yeah, okay, because what I said yesterday is that, okay, as far as the relationship between power and intensity, they were directly proportional with no squares, no cubes, nothing. So if the power reduces to half, then the intensity is also going to reduce to half. Did that make sense?
Yes.
Clear? Okay. Question 14. So because yes, okay, the answer had been true. Had it said that the power, sorry, the amplitude reduces to half, is the intensity, or could it have been power, or had reduced to, yes, okay, 1/4 of the original, then your answer had been true. Okay, so if power was replaced by, sorry, if you said, okay, here power was replaced by amplitude, okay, then yes, okay, and intensity, and they have written intensity, yes, okay, or even if they had written power instead of intensity, then it's okay, 1/4 would have been the correct answer. But here, since they compare power and intensity directly, okay, nothing is being squared, nothing is being cubed, or so and so. So that says, okay, why it becomes false. Yeah, okay. It would have been true between power and intensity had the not said 1/4, but did you guys get that?
Yep.
Good. Question 14. So true and false. So propagation speed increases if there's an increase in frequency. And that's false. And why? Mainly because, yes, okay, propagation speed and power are not related. Forget about being directly proportional, forget about being inversely proportional. They are not related at all. So you can increase or decrease the power, yes, okay, frequency as much as you want to. It's not going to lead to an increase or decrease in the propagation speed. Why? Mainly because, okay, these two dudes here are not related. Yep. Now, guys, the type of question that you may see is okay a lot of, where there's okay compare two things with one another. So we may guess okay, we'll say okay, do we have a medium 1? And okay, yes, we have a medium 2. Yeah, okay. Now what medium 1 has is, well, okay, yes, we guess it's okay, that's going to be density. So yes, okay, medium 2 has a density of 9 and a stiffness of 6. And medium 2 has a density of 8 and a stiffness of 6. Yep. Okay. Now what they ask us is that's okay, in which medium is the sound going to travel slower? So what the main is okay are looking about is okay, which of these two media here has the slowest propagation speed? Did you guys get that?
Yep.
Good. Okay. Now the first thing to look at, okay, yes, is okay, yes, what is the relationship between, yes, okay, the two things that we have here. First, we can say, yes, okay, that the propagation speed is directly proportional to the stiffness. Clear? Okay. And it's going to be, yes, okay, inversely proportional to the density. Now, what you may see in questions like this, okay, and especially as okay, as we see an example here, is okay, the stiffness of both media is the same. Did that make sense?
Yep.
Right, okay. The stiffness of the medium as okay is the same. So what we mainly as okay just are left with is just okay determine as okay what's going to be as okay having the slowest propagation speed, or to work with is going to be as okay the densities. Now what we need to find is okay as the lowest propagation speed. Okay, lowest propagation speed. Okay, that we know is inversely proportional to density with main domain, that's okay. We'll need to choose the one with the greatest density, with this medium one. Did you guys get that?
Yes.
Okay. Now let's say that's okay, the same question. That's it. You can say the same data. I had to ask us about it's okay, the fastest propagation speed. Now, like, of course, that's okay, since the density or the stiffnesses were the same, we couldn't really use that because they both will have, that's okay, the same effect on the propagation speed. But then yes, okay, we just have to look for the one with the lowest density, because density and propagation speed was directly proportional. So yes, okay, you want to find that greatest speed, the fastest speed, you would like to look for the one with the lowest density, which would have been medium 2. Did you guys get that? Right, okay. Now, if let's just say that, okay, yes, our densities had been the same. Let's just say it's okay that they both had the density of 6. And they still asked about, yes, okay, what is going to be the slower propagation speed. Clear, okay. That is okay. Now let's just change, that's okay, our stiffnesses. You can say it's okay. 8 and 10, for instance. Now, if they ask for the slowest speed, then your range is okay, look for the one with the lowest stiffness in this case here, because the densities would have been the same. So the lowest stiffness would have been in 8, which would have been the lowest speed. If they ask for the fastest speed, then it would be 10 because of the greater stiffness. Did you guys get that?
Yes.
Okay. So it's all just okay, a matter of what you want to call it, relations. Okay. Question 16. Now, which of the following characteristics will create the fastest speed of sound? Okay, and as many as okay, just the 2 characteristics that we have. We have density and we have stiffness. Okay, now if you know the relationships, it's straightforward, guys. Now, first, that's okay, what are they looking for? The fastest speed. Their speed was inversely proportional to density, so you may as okay, or need to look for the one with the lowest density. And it was directly proportional to stiffness, so high stiffness. Okay, but what you can do is okay by just saying it's okay, I will only need the ones which has okay low stiffness. You can actually it's okay just do an elimination of A and C. Because it's okay, both A and C has high stiffness. Or high density, sorry. Okay. Which is not what you're looking for because you're looking for the highest speed. which would require low density. Okay, where you just are left with, okay, is B and D. And now you just have to look at, okay, which of these two here is, okay, has high density, high stiffness. Clear, okay. And that will be B as in boy. So that's your answer. So an easy way to just, okay, answer questions like this one here is, okay, is just okay, first, well, look at, okay, what they're looking for. Okay, look at, okay, the criteria that you have. Well, that's okay, or yes, okay, that's okay, yes. And okay, establish that and based on the relationship. But okay, you come across things like this, that's okay, you can directly eliminate that because that's not going to give you the low density, sorry, high grade speed. Because A and C said high density, which will give you a low speed because they were inversely proportional. Yeah. Now, guys, question 17. Maybe that's okay, I guess the exact opposite of 16. So what are they looking for is, okay, which of the following characteristics will create the slowest speed? Okay, and again, yes, okay, we have the same criteria. It's okay, we have, sorry, density, and we have stiffness. Now, guys, maybe that's okay because we are looking for the lowest speed. And we know speed is inversely proportional to density, so we need a high density. Since we are looking for lower speed, and speed is directly proportional to density or stiffness, we look for low speed. That's it. Okay. But that's okay, just to eliminate, yes, okay, what's our options? Will be as okay, eliminate the one with high density, and that will be A and C are out. Did that make sense?
Yeah.
Good. Question 18. Now, if the power in a beam is 1 watt, so we have a power which is 1 watt, and the area is 5 centimeters. Square. Okay, what is the beam's intensity? Now, if you know the formula for intensity, that was power divided by area. And now you just put the numbers in, which will be 1 over 5. Now 1/5 is the same as saying it's okay, 0.2. Now, how you know mathematically is okay that this is correct? Mainly by saying that, okay, yes, if 0.2 is multiplied by this, did that make sense? Yeah, okay. So your intensity is going to be as okay 0.2 watts per centimeter square. Now, what could have been the question to make question answer number 1 correct? Well, okay, we could have said it's okay that you had a power of 25 watts divided by 5 centimeter squares, or an area of 5 square centimeter. Then, okay, that's option E, which is 5 watts per centimeter square, will have been the right answer. Option B is okay. Okay, says okay, 1 watt per 1 centimeter square. Clear, okay. Or 5 watts by 5 centimeter square. What I come out to is okay, 1 watt per centimeter square. Option D could not be the answer because okay, they didn't ask about the power, but the intensity. Yeah, okay. Right. So today is with help of intensity, is okay, you want to calculate the power. Well, okay, you have to have the value of the intensity. You can say, it's okay, that's okay, we said, okay, 5 watts in an area of 5 centimeters squares. And then if they ask you, it's okay, where is the power? Then you gotta go and says, okay, 5 watts divided by 5 centimeters square. That's okay, power is 1. And it's going to be, it's okay, 1 watt. Did you guys get that? Okay. But if I just give you an intensity and say, well, okay, this is your intensity, without giving you an area, and say, okay, what's the power? You have no idea to yes, okay, be able to calculate that. Okay. So in an equation like this, or in an equation like these, as okay, you would need at least 2, or it's okay, you at least would at least need to know as okay the value of 2 criteria, parameters, or factors to determine the third one. Okay. If I say it's okay, 20 cookies in a jar, how many cookies will each person get? You say, but how many people are we talking about, right? Okay. Clear? Did that make sense? So if I says, okay, 20 cookies in the jar and okay, yes, 5 people. Then you can say, okay, now each person is okay, will get 4 cookies. Yeah, okay. The only reason that, okay, yes, the number of people may not count and so on and so and so is if I says, okay, 20 cookies and Cookie Monster. Then, okay, nobody get the cookies. Right, okay. You guys want to take a breather? Okay, guys. I see you guys back at, should we say, you say, 11. Okay, guys? Hey, guys. Welcome back. Okay. Now, any questions so far? Nope. So are you getting a little bit of idea of what questions can be ASKED? How to use the material that we have talked about so far. Good. Let's proceed. Question 19. Now, if the intensity remains the same while the power is doubled, what happens to the beam area? Now, just look here, guys. We see it's okay. Intensity, yes, okay. That was included directly proportional to the power. And okay, it was inversely proportional to the area. Now, what they say here is that, okay, yes, the power is doubled, right?
Yeah.
Yeah, okay. But in spite of that, they say, well, okay, listen, guys, the intensity, yes, okay, still remains just the same, which means that, okay, yes, it will not increase or decrease. Okay. Although it's okay, the power is doubled. Now, okay. Now, have you, for instance, okay, kept the area constantly as okay by doubling the power as okay, what will it cost or what will happen to the intensity? It will also have doubled. But that's not going to happen. So they're asking, okay, what's going to happen to the area? Although it's okay, we double the power, but the intensity is going to just okay remain the same. And that will mainly mean that, okay, yes, the area is also going to be doubled. The remaining can say, okay, now what happened here was doubling the power as okay would have doubled the intensity. But as okay, at the same time, we also as okay double the area. That is going to as okay half the intensity. That was doubled by doubling the area power.
So why does it say the intensity stays the same?
Because that's what they wanted you to do, in spite of the power being doubled. Now this, okay, I know this is a little off question, but look, if the intensity remains the same, which mainly yes, okay, mean that okay, yes, the intensity will not increase, neither will it decrease. Clear?
Yeah.
Yeah, okay. While the power is doubled. So it's okay, we doubled the power. Okay. Did that make sense?
Yeah.
Good. So what they're asking is what's going to happen to the beam area or the area of the beam. And that is also going to be doubled. Okay. Or let us do it this way, guys. Okay, it's probably much easier. We can just say it's okay. Let's say that, okay, yes, we have an intensity. Let's just say that, okay, as our intensity is 2 watts per centimeter square. Is that clear?
Yeah.
Good. Okay. Now we can say, it's okay, how did we get that intensity? That was mainly, it's okay, because it's okay that our power to begin with was, let's say, it's okay. Well, let's just say it's okay. Was 2 watts. And it's okay, our area was 1 centimeter square. Is that clear?
Yeah.
Good. Now what they say here is that, okay, yes, our intensity is okay, will remain the same. Although it's okay, we doubled the power. So if that was the case here, that's okay. Now what was going to be is okay. The intensity would have been is okay, become 4 watts per centimeter square, right? Okay, which is not true in accordance to the question. Clear? Okay, so what they say is okay, all this okay, we double the power. What would be the change in the area? Yes, okay. That will be required to still keep the intensity the same, although it's okay, the power was doubled. And that will mainly mean that, okay, yes, we will also have to, yes, okay, double the area. Then you then can say, it's okay, now all that's okay, the power after being doubled becomes 4 watts. But since we also, it's okay, double the area, is going to be 2 centimeters squared. And now you just put that into the equation. 4 watts per 2 centimeters squared. And okay, yes. Come 2 watts per centimeter squared. Did you get that?
Yeah, it makes more sense with the numbers. Thank you.
Right, okay, okay. So what they mainly did here is, okay, I know it's okay, there are going to be some questions that you'll come across where the word is a little bit like, okay, what the, is it that, okay, he wants? Yeah. Okay. So what they did was they said, okay, in spite of increasing the power or doubling the power, okay, or your intensity still remains the same. So what do you need to do to the area? Okay. Now you can then go and say, what if the power increased 3 times? What will you need to do to the area to keep the intensity constant or the same?
Triple it.
Triple it. Okay, so the 3-time increase in the power is okay if the area had remained unchanged, or a cause, okay, as that the intensity would have increased 3 times as well. But increasing the area 3 times as well as we increase the power 3 times is going to just, okay, just, you can say, okay, make the intensity just, okay, decrease back to 1/3 and still remain the same. Does that make sense? So on one hand, yes, okay, you increase it. On the other hand, yes, okay, you decrease it. And okay, yes, you still remain the same. Did you get that? Okay. But sometimes, yes, okay, there may be a question where it's okay, it may help a little bit more. So yes, okay, just put in fancy numbers. Of course, that's okay. But don't make it more difficult for yourself. Question 20. Now, a sound beam's total, okay, a sound beam travels a total of 10 centimeters in 1 second. So we can mean says, okay, that the distance traveled is 10 centimeters in, okay, sorry, 2 seconds. Yeah, okay. And what they just ask you is, okay, what is the speed of this sound here? So if you say that, okay, as this here is, okay, was a distance of 10 centimeters and it takes the sound 2 seconds to travel that. What's the speed? Now you can maybe it's okay, just get that from speed because okay, where was it the speed was? And that's why I says okay. Mainly it's okay, just knowing the unit will tell you it's okay what you do. Because okay, it was distance by time. So you can mainly say, okay, the speed of the sound is going to be 10 centimeters per 2 seconds. Now, guys, do we have that as an option?
No,
You may say it's okay, 10 centimeters per second, but that's not the same as 2 seconds because, okay, here was taking the time off 2 seconds. Okay, so be careful. It's not going to be 2 centimeters. 2 centimeters would just have been this distance here, for instance. Per second, right? Okay. 5 centimeters per second, okay, or 0.2 centimeters per second. Now you just have to just okay, notice okay what to do. 10 divided by 2 becomes 5 centimeters per second. Okay, so yes, okay, you could very easily, yes, okay, had got the thing wrong had you not known. Yes, okay, your units, or yes, okay, what the speed is calculated, because had you gone by time, by distance, you could have got option D and say, okay, well, that's the right answer, which is not. Yeah.
yeah,
So that's okay. An easy way to just okay calculate things like this is just okay, no. And if it can be as okay simplified. Okay, and if it can be simplified. Okay. And it says okay, 10 meters per 10 centimeters per 3 seconds. But okay, it's going to be R just okay divide 10 by 3. But in this case, it's okay, 10 and can be divided by 2. Okay, yes, why not write in a simple form? Question 21. True and false. So does the propagation speed increase as the frequency decreases? That's false. Not because that propagation speed and frequency are directly proportional, but mainly because, okay, these two guys here have no relationship to one another. Clear? Okay, so it's not going to be that, okay, yes, just if you say, okay, that the frequency increased because an increase in speed is going to make it true, even that had been false. Because that these two dudes here are not related to one another. So you really can't. Okay, so in changing the value of one is not going to change in the value of the other. Okay, so that's why that's okay. Question 22 is false as well. Mainly because that's okay, that propagation speed. Okay, is it true to say that it increases? Okay. If the frequency increase. That was 21, sorry. So it's going to be it's okay. It's going to be 22. Right, okay. But in both instances, okay, that will be false because propagation speed and frequency are not related. So you can increase one, it's not going to affect the other. You can decrease it, it's not going to affect the other. You can change the frequency, either increase it or decrease it, it's not going to affect the propagation speed. Is that clear?
Yep.
Good. Question 23. And again, yes, okay, we say true and false. So what the main says, okay, here, the propagation speed, no change as the frequency increases. So if we increase the frequency, is it true to say that the propagation speed will not change? Yes. Why is there no change? Because that they were not related. But even as okay, my dear, even if you flip it around and say that says okay, increase in the propagation speed, and okay, there's no change in the frequency, you that would have been true. Did that make sense?
Yep.
Okay. Now, guys, please, 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 here's okay, this propagation speed here is going to be as okay, the speed of the sound that leaves the transducer. Okay. In a later chapter, okay, we can check it out. But the frequency then going to is okay, be directly proportional to that's okay, some sort of speed, but not the propagation speed. Okay, guys. Okay, let's just clear this out here. Otherwise. Okay. So how many questions so far have you actually as okay needed to do math? That's the one that we talked earlier about. It's okay about the propagation speed where we calculate the speed, right? Okay. And okay, that's where we calculated, I think it was, what was it? Question 18, where we calculated the power of the intensity, right? Okay. Good. Let's see, question 24. Now, okay, as what is the wavelength of a 3 megahertz sound wave in soft tissue? So what do we have? They specify the tissue. Soft tissue, and they ask, okay, as what is going to be the wavelength if the frequency was 3 megahertz? But that wavelength was going to as okay be 1.54. We know that okay, as this will be millimeter, and that's going to call that okay, the wavelength will be expressed in millimeters as well, just because that happens to be the unit. And okay, as our frequency here was 3 megahertz. So that becomes 0.5 millimeters. Yeah. You remember that formula or equation here?
Yep.
Good. What if I had said that, okay, that's the frequency, or had been thirty megahertz? What do you think your wavelength would have been then?
Point zero five.
Huh?
0.05.
0.05. Horses or donkeys?
Millimeters.
Millimeters. Good. Now, guys, and this frequency here, let's just say it's okay, 3 megahertz. Can that be written in another way? Of course. 3 can be 3. We can say, or mega can be 10 raised to the power 6. And the hertz can be hertz. Is that clear?
Yep.
Good. Likewise, guys, our 0.5 millimeters. Can that be written in a different way? Of course it can. Well, okay, we can still say it's okay, 0.5, for instance. Will still be 0.5. Now the milli is this. Clear? Okay. And you can say it's okay, the meter is, well, okay, yes, still meter. And or we could even just okay write it as a whole number. Of course, it's okay, 0.5 becomes 5. Okay. Now at this 10 point raised to the power minus 3. What you actually it's okay will do is okay, yes, you will add another minus 1. And then you still okay, it's without meter. So it becomes 5 multiplied by 10 raised to the power minus 4 meters. Did you guys get that?
Yep.
Now question 25. Now, what is the wavelength of a wave with an unknown frequency traveling through soft tissue? Now this says, okay, where is our wavelength? Now here's, okay, not known frequency. And okay, but this still says, okay, that this is a soft tissue. Now, theoretically speaking, guys, since says, okay, the frequency is not known. Well, okay, yes, can't be determined. Okay. But then as okay, when we look at the option 0.51 microseconds, well, okay, that cannot be the option or that cannot be the answer because microsecond is not a unit for wavelength. That would have been a unit for period. Clear? Is that clear?
Yes.
Good.
Yep.
0.15 meters per second. Well, okay, that can't be it either. All this, okay, meter is okay as a unit of distance, but it's going to be meter per second. So 0. Also meters per second, that's going to be the unit of speed. Yeah, okay. C is 0.15 pascals, where, okay, Pascal is not the unit of wavelength either, it's the unit for what the unit, or the Pascal is the unit of what?
Pressure.
Huh?
Pressure.
Pressure. Exactly, good. Okay. Next is 0.5 watts. That cannot be it either because watts is a unit of
Power.
power. Clear? Okay. And 0.1 meter or 0.1 millimeter. That can be it. Clear? Okay. Because that's the only one that, okay, represents that's okay, I has the unit of wavelength. Clear? Okay. Had we not had options, okay, yes, okay, okay. But mathematically, yes, okay, it would not be, yes, okay, you couldn't determine it. Mathematically, because you need to know the frequency, okay, to calculate the wavelength. Okay, so the reason that, okay, option E as an elephant or everything is the right answer is because that's the only one that has the unit of wavelength. Otherwise, everything was 0.1, 0.1, 0.1. But then my question here would be as, okay, if that was the wavelength, what would have been our frequency then?
3 megahertz.
3 megahertz, exactly, good.
So for this question, like technically if the options were like any number, we would just be focusing on the unit.
Well, okay, you can say for this question, yes.
Yeah.
My dear, in case of multiple choice question, where you can only work or you can only answer from the options that you have. Is that clear?
Yes.
Good. Okay. So although it's okay in our previous question, I hope I don't erase that. Did I? Well, okay, you calculated this one here. You don't see as okay exactly this one here as an answer, but you rather see this one here. Well, you can even it's okay. Oh, shit. What the? Don't do that with me now. Okay. You this here, this answer would have been the same. It's okay, correct because it is the same as this. Or you it's okay, this answer here would have been correct, although it's okay, this is what you calculated out. Well, it's okay. This might have been the answer that you have been given. Okay, so you can only work as okay, you can or you have to work with the options that you have been given. Yeah, okay. But if I ask you, yes, okay, what is going to be the sound wave or what's going to be the wavelength of a sound wave with an unknown frequency traveling in a soft tissue? Well, okay, the correct answer would have been yes, okay, it can't be determined. Because, okay, you will need to know the frequency to be able to calculate the wavelength. What do you get from the soft tissue is okay, just that 1.54. Did that make sense?
Yep.
Good. So the reason that E as elephant is the right answer here is because that's the only of the options that has, okay, as the unit that represents wavelength or distance. Okay, let's put it this way. Now question 25, 26, sorry. So now they're asking us, okay, what is the wavelength of a 2 megahertz sound wave or sound in soft tissue? Again, it's okay, what's the wavelength? In soft tissue. If we have a frequency of 2 megahertz. So it's the very same case again, yes, okay, 1.54, sorry, divided by 2 megahertz, right? Okay, or whatever frequency you're given. And that's why I said, just memorize that one. Just give me a second, guys. Just a second. So yes, okay, it's going to be yes, okay, this many millimeters. Yeah. So this 15 is okay, 1.54 is going to be yes, okay, 0.77. Okay. Did you guys get that?
Yep.
Good. Question 27. Now the effect of a sound wave, okay, sorry, the effect of a sound wave on the tissues in the body is called biologic effect. Whereas guys had it been worded the other way around. The effect of the tissues upon the sound wave that would have been an acoustic propagation property. Did you guys get that?
Yes.
Question. Number 28. Now, which of the following are considered as acoustic variables? So they are giving us different things. Okay. Now, first one is going to just be frequency. Is that an acoustic variable? No. As a matter of fact, that's going to be an acoustic parameter. Clear? Okay. Density. Is that an acoustic variable?
Yep.
Yes. Clear? Okay. Particle motion. Okay, maybe a little weird, but okay, as what they mean is I meant here was distance of particle motion. So of course, that's a variable as well. Temperature
No.
is not an acoustic variable. As a matter of fact, it's not an acoustic parameter either. Clear? Period. That's not an acoustic variable, that's an acoustic parameter. And pressure. Yes, okay, that is an acoustic variable. Okay. Now, that's okay. Two things that many people may confuse. Me, that's okay because they sound alike. Is intensity and density. So please keep in mind, guys, the intensity is that is an acoustic parameter. And density is is an acoustic, or density is an acoustic parameter, or variable, sorry. Question 29. Now, which of the following are considered as acoustic parameters? Okay, and again, yes, more than one answer may be correct. Okay. So, is frequency an acoustic parameter? Well, okay, we already said that. Yes, it is. Density is not, because that was an acoustic variable, right? Okay. We can say, distance is not because, that was an acoustic variable. So it can't be both. Okay, they say pressure, but it can't be an acoustic parameter because it's an acoustic variable. And then they say period. Well, okay, we already said that. Okay, yes, it is an acoustic parameter. So that's what they're asking about here. Clear? Okay. Had it said dense intensity, as well as, that would have been a acoustic parameter. Had it said power, that would have been, as an acoustic parameter. Had it said amplitude, it will be as okay acoustic parameter. And it says okay something like distance per time. Acoustic parameter. Why? Why would distance per time be an acoustic parameter?
That's your propagation speed.
That's your speed, which is an acoustic parameter. Question number 30. The effect of sound waves upon the, let's say it's okay, the effect of tissue, sorry, upon the sound waves are called. That's okay. Effect of tissue on sound wave, called your acoustic propagation property. Clear? Okay. And what we mainly as okay may say that okay, this effect here that the tissue has upon the sound wave is that okay, yes, that the power, that the intensity, and the amplitude of the sound wave will reduce as it passes through tissue. Is that clear? Is that clear?
Yes.
Yeah,
Good. Oops, shit. I don't know what I meant to do. But just to ask, okay, yes, a dumb question. Is there anything else that, okay, yes, of the sound wave that can be affected as it passes through the tissue? Yes, guys. Is there any other effect that the tissue may have upon the sound wave?
Yeah, the power, intensity, and amplitude will all decrease.
Oh, we already said that, my dear. Or what else? What could be another? Is there any other effect that the tissue has upon the sound wave?
The propagation speed?
Who said that?
Caitlin.
Caitlin. Exactly, dear. Oh, sorry. What is that going to be? What's going to be the effect of the sound waves propagation speed by the tissue?
Like whether it's solid, liquid, or gas depends on like
You can
solid.
say it's okay.
Acid. Yeah.
Okay. So all dependent upon is okay, the nature of the tissue will set the speed of the sound wave. Okay. The effect of the medium on an ultrasound wave is called the very same. Because, okay, your tissue in ultrasound is okay, or what we just in general call medium, right? Clear? In ultrasound, we call the source
Transducer.
transducer. Or generally speaking, yes, okay, will just be the source. So question 30 and 31 is the same thing. Or where it just says, okay, replace the word tissues out with media. Did that make any sense? Good. Question 32. How are the following parameters related? Directly, inversely, or unrelated? So cover the answers, guys, and okay, yes. And I'm going to do the same. Blank piece of paper. Answers covered. So do you. And there's a limit, or there's a time limit. Ding, ding. Frequency and period,
Inversely.
inversely. A better option,
Inversely and reciprocal.
reciprocal. Caitlin, reciprocal automatically means that they are inversely related. Okay, dear? Clear? Okay, good. Amplitude and power. Directly related.
Directly.
Okay, good. Amplitude and intensity.
Directly.
Directly related. Good. Power and intensity.
Directly.
Directly. Good. Wavelength and intensity.
Unrelated.
Unrelated. Good job, my dear. Okay, wavelength and frequency.
Inversely.
Inversely related. Any better option?
Reciprocal.
No, they're not.
Oh no.
Don't fall for my slippery black ice, okay? Okay, dear? They are not reciprocal. If they had been reciprocal, then you wouldn't have had that fixed value, 1.54. Okay. You have said, okay, as the frequency of 2 megahertz could have been as, okay, half a millimeter, for instance. Okay. Something like that. Okay. 4 megahertz is, okay, 1/4 of a millimeter or something like that. That would have tended to have been reciprocal. But that's not the case. Did that make sense? Okay. So the reciprocal, guys, only applies for us, okay, when we talk about something in terms of the frequency and the time it takes. Yeah, okay. Okay. Acoustic velocity and density. Now, some of you may be scratching your heads and say, what the is acoustic? Does anybody know what acoustic means? Or is
Sound.
sound or pertaining to sound, right? Okay. Velocity is
Speed.
just going to speed in direction. Yeah, okay, we'll talk more about it. Okay, velocity in chapter 19 or 18. Okay. But I think I already mentioned that, so that's okay. And is that yes okay? How is that related to compressibility?
You mean density?
No, compressibility.
Oh, we were on density.
What did I say about compressibility yesterday?
It's elasticity, right?
Mhm,
And your stiffness.
mhm.
Okay.
Okay, so how are they related now?
Directly.
No, but compressibility is the opposite of stiffness. Just think of something, yes, okay, here, yes, okay, this is my iPhone or whatever you want to call this. This dude here is stiff because I can't squeeze him together, right? Okay. I may be able to do it, but okay, yes, then you guys pay me for a new iPhone. Just because I had to demonstrate it. Right, okay. Okay. So compressibility and acoustic velocity or speed of sound is
Inversely.
inversely related.
We weren't on this one though. We were on the density one. We're on
Okay,
the-
sorry. So they weren't being inversely related too. Sorry. Okay. So okay. I guess okay, we jumped one. Sorry. Oh, we even jumped, that's okay, because there's okay. Elasticity and speed of sound.
Inversely.
Inversely. Because elasticity is just the opposite of stiffness. Clear? Okay. Okay, and okay, compressibility, yes, okay, that's also going to be inversely. Now we talk business. Stiffness and speed of sound
Directly.
directly. Frequency and speed of sound.
Unrelated.
Unrelated.
Okay. Frequency and intensity
Unrelated.
are related. Okay, power and frequency
Unrelated.
are related. Power and amplitude
Directly.
ah,
Directly.
good. Okay. Pressure and amplitude
Not related. Final answer.
What could we measure amplitude with? What were the units in which, yes, okay, amplitude could be measured? Your three acoustic variables, right? So you can say, okay, they're most likely, yes, okay, will be directly related. Period and amplitude. Bam. They are unrelated. Density and area.
Directly.
Inversely.
Unrelated.
Density and area is
Yeah.
going to be volume and area density. That will be volume and density are
Inversely.
inversely related. Good. So guys, it's not all yes, okay, relationship that I may ask about that will be related. Okay, guys? Okay. So how did you like it? Did it help? Okay, so you guys may have, okay, it's a little bit of idea of this, okay, what kind of questions can be asked. Okay, guys, now after lunch, yes, okay, yes, there's a hell of a series of questions here. Let's see, oh shit. OMG. That's almost 80 questions in the exam review. Even more than 80, to be more accurate, 88 questions. So let's see how far we can get with those. Okay. Well, let me put this way as okay. We as okay are able as okay. If you are able to as okay understand these questions, one of the major as okay points or topics in the following chapter will be easy to understand. Okay. And I'm in no rush. We are ahead of time. Okay, guys, I see you guys back at, should we say 12:50? Is that a deal? Okay, guys, have fun till then. Okay, guys, welcome back. Now, at this moment here, any questions? Nope. So everybody's good? Good. So let's just see if we can continue and how far we can get. Okay, guys, so I will take you guys to $432. And okay, yes, we'll start with question number half of a century. Now, question 50 starts of, okay, yes, what is the range of periods commonly found in waves produced by ultrasound systems? Right, okay. So mainly, yes, okay, just the typical value of period which was 0.06 to 0.5 microseconds. Is that clear?
Yeah.
Good. Now, a standard ultrasound imaging, what happens to the period of a waves as it propagates? So me is okay, what does this say? Is okay, you know, this was a sound wave. Okay. Now yes, okay, the wording is okay with standard ultrasound imaging. That's just okay, just to confusion. Okay, nothing. But as a sound wave travels through the tissues, what's going to happen to the period? Will the period increase? Will the period decrease? Or will it remain the same?
Remain the same.
Remain the same. Okay. Clear. Okay. What will happen to is okay, what will decrease for sure had been is okay, power, intensity, and amplitude. That's what it says, okay, for sure will decrease. Okay. Wavelength and or is okay, speed depends upon it's okay, the tissue. Question number 52. What determines the period of an ultrasound wave? Okay. So guy, when we say it's okay, determines, well, okay, yes, it could either be as okay. Or source or medium. Okay. Or it could be both. Or none. So yes, okay, all things that we have discussed, period of each cycle was determined by the source. Okay. 53. Now, which of the following units are appropriate to express, okay, to describe the period of an acoustic wave? More than one answer may be correct. Okay, so the only thing that they want to show is, okay, is, okay, do you guys do you guys know what will be as, okay, the kind of units that is going to be as, okay, used to be for period, which is mainly as, okay, is going to be as, okay, any unit of time. And you know what a unit of time is going to be? Minutes. Yes, okay, that's one of them. You can say as, okay, microseconds. That's also. They just happen to, yes, okay, be 1 or 1,000,000 of a second. Yeah, okay. The next one is meters. Well, okay, that can't be the one because that is the unit for distance or length. Yeah, okay. Millimeters per microsecond. Well, only this part here is okay as a unit for Peter, but that together with millimeters or unit of distance, that's what become this unit of speed. Yeah, okay. Cubic centimeters. Now centimeters cube. Now don't fall for this here, it's okay being a distance. Because once you start squaring, cubing it, so on, so on, so it ends up becoming something. So that's going to be, okay, the unit of volume. Yeah, okay. Okay. So it's only minutes and seconds that can be used to yes, okay, document period. Any question, guys?
No.
Nope. Good, but okay, these are the simpler questions. Okay, true and false. So question 54. True or false? The sonographer has the ability to alter the period of an ultrasound wave that is produced by a basic transducer. It doesn't really matter whether I say basic or say a transducer. The answer is this statement here is false because we can't adjust the period. So just for now, yes, okay, at least think, okay, at the period of sound wave produced by any transducer is constant. Okay, guys? This thing here is going to, yes, okay. No, okay. This thing is going to, yes, okay. Help you, yes, okay, in the next chapter. Okay. What the hell? Question 55. What term describes the number of cycles that an acoustic variable completes in a second? Yeah. Now here is okay, guys, is number of cycles. Okay. Per second. And that was already called frequency. Yeah, okay. And it said yes, okay, the time to complete a cycle that would have been period. Okay. Variable rate is nothing. And some of you will say, okay, what is a pulse repetition period? Well, okay, that's some of the thing that's going to be, okay, something that we'll come across in chapter number 4. Okay, so some of these answers that's okay here in the back of the book is some of the questions I made is okay asked because they thought that you already have like okay, finished the whole book before getting to these questions here. Okay, guys. So for now, it's okay. Don't bother about it's okay. What pulse repetition period is. You will hear more about that, a lot of that, in the next chapter. Now, which of the following cannot be considered a unit of frequency? Okay. Can't be considered frequency. Now, per day. Well, okay, that can still be as okay frequency because is okay, is because per time. Okay. Cycles per second. Yes, okay. That's what we said. Okay, yes. Or frequency was going to be. Hz is just the symbol or what we call hertz, which is okay as the unit of frequency. And okay, yes, hertz is hertz. So that is that's the unit of frequency, and this was just the symbol of it. Whereas cycles, well, okay, as you can see, this, but this is not a frequency. This is just a cycle. Okay, the frequency will mainly be as okay, how frequently is it that a cycle appears or occurs? Question 57. Now, what is the range of frequencies emitted by transducers used in ultrasonic imaging? So again, it's okay, the typical value of ultrasound transducers. Now, you said that there was 2 to 15 megahertz. So 1 to 3 megahertz is out of question. Okay, 1 to 100 or 100, always okay, 1000 kilohertz. It's also out of the question because 1000 kilohertz is just going to again just be okay. Be 1 megahertz, which is lesser than the minimum. Now they say it's okay, minus 10,000. Two, that's okay, plus 10,000 hertz. Now that can't be it either, because okay, of course, it doesn't fall in this. Okay, but just keep in mind, guys, okay, this minus 10,000 hertz. It could also be written as 1 over 10,000 hertz. Or we can say, okay, 1 multiplied by 10 raised to the power minus 4 hertz. Okay, although as okay, there is nothing known as negative frequencies. Okay, especially as okay, we talk about sound because that mainly means that okay, it takes the sound in more than 1 second to complete one cycle. Did that make sense? Okay, but this minus 10,000 could actually just okay, just be this here as well, or this. Did you guys get that? Okay, so that's where we left with as option D, which is mainly as okay, just 2. Well, okay, yes, a hell of zeros. But this is 1,000, and this is 1,000. So 1,000 is a mega, and then 2. Did that make sense? And so is 15. That's okay, just with those 6 zeros. Right, this is 1,000, and this is 1,000. Right, it's going to be okay, 10 raised to the power 3, plus, okay, because that's okay, times. Actually, it's going to be like this, but that's okay. We can actually just okay, just add these, and it becomes 10 raised to the power 6, which was a mega. You guys get that?
Yep.
Key. Okay, what establishes the frequency of an ultrasound wave? Now, if you guys don't know what the mean here is, okay, by establish, you can say, okay, makes or produces. Or what it means is, okay, I talked about in terms of in the book or chapter was determined by. Clear? Okay, so again, yes, okay, is the source, is it a transducer, or is it both, or is it neither? And is the transducer, which in this case is okay, will be our source. Question number 59, which is true and false. Now, what this means is, okay, states is, okay, as with standard ultrasound pulse. Okay, it's okay, standard ultrasound pulse. The frequency of the sound ultrasound changes significantly as the wave propagates through the body. Now, don't get thrown off by a lot of these fancy words here for now. But what they mean is, okay, it says, okay, is does the frequency increase or decrease as the sound wave propagates in the tissues? If the answer to that is no, then this statement here is okay, is false. And that's what it is. Okay, so your frequency does not change as the sound wave travels through the tissues. Clear? Okay. If it was, let's say it's okay. 10 megahertz here. It's going to remain as okay, 10 megahertz, no matter as okay how deep it travels. Is that clear?
Yeah.
Okay, or at least for now. Question number 60. When a sonographer increases the maximum imaging depth of an exam, what happens to the frequency? Now, mainly as okay, just what I said. This is your image. We can say as okay, right now as okay, we are going to a depth of 5 centimeters. If we increase this depth here to, let's say it's okay, 10 centimeters, what's going to happen to the frequency? Now, indirectly, as okay, we already answered that question. That frequency remains the same. Because that's okay, the transducer might have produced, let's say it's okay, 2 megahertz. At 2 megahertz, that wave travels deeper and deeper and deeper and deeper. The frequency of your sound wave Now, please mind my words, the frequency of your sound waves is still going to be as 2 megahertz at all these depths. Even if you go from from 5 centimeters all the way down to 10 centimeters. The frequency of your sound wave will remain the same. Did you guys get that? Okay, now again, guys, now the trick in this question here, we get clear as once we do chapter 4. Okay, the trick in this question is going to get clear when we do chapter 4. Because there will be something in chapter 4 that we'll talk about that will change. And as a matter of fact, it has the term frequency in it. Okay. Clear. Okay. So you have to distinguish between plain frequency and that new characteristic or parameter or term. It has the word frequency in it. Because that other fellow will change. But your regular frequency does not change. Is that clear? So this is when ultrasound physics is going to start to become interesting. Okay, but frequency, guys, does not change. Okay, echo trials, don't do that on me. Air shell at depth is 2.5 centimeters. You can go to 5 centimeters. You can go to 7.5 centimeters. You can go to 10 centimeters. You can go to 12 centimeters, 15 centimeters, 30 centimeters, whatsoever. That frequency is does not change. Question number 61. Ultrasound is defined as a sound wave with a frequency of now it says ultrasound waves was at greater than the human audibility. Where we could say the max of the human audibility was 20 kilohertz, which becomes 20,000 hertz. Okay. Now don't fall for option A. Because what option A actually is 20,000 kilohertz, where it actually becomes 20,000 kilohertz actually becomes 20 megahertz. Because as I said earlier, this is 1,000. And this here is another 1,000. And 1,000 becomes a mega. And 20 is 20. Did that make sense?
Yeah.
Okay. So yes, the 20 is correct, but then it's what else comes after it is making a hell of a difference. Okay. Less than 1 kilohertz. No. Okay, that's not going to be the case. Greater than 10 megahertz. Okay. Now 10 megahertz again, that's okay. Of course, that's okay. It is ultrasonic. Okay, but that's not going to be as okay you can say it's okay. The beginning. So that's why it's okay. It is wrong. Even then, if that was the case, that's okay. Then we're gonna say okay, it's 20,000 or 20 megahertz would have been the correct answer, or 20,000 kilohertz. So greater than is okay. Yes. Now we go 0.2. Megahertz. Where okay, as there's 0.2 here, actually it's okay, it becomes of a megahertz is 1/100th of a megahertz, which is going to be a kilohertz. Did that make sense? And then okay, yes. Okay. Then it's going to be it's okay, another 10. Well, it's going to be a multiple. That just makes it okay. Clear. Any questions?
Oh,
Okay, good one. '62. The infrasonic, yes, okay, waves is defined as an as a wave with okay. Infrasonic is defined as a sound with a frequency of, yes, okay, less than 20 hertz. Okay. Yeah, okay. So main, yes, okay. So just keep in mind, okay, yes, that you need to know the audible range, which was 20 hertz to 20 kilohertz. Anything less than this is infrasonic. Anything is okay greater than this is ultrasonic. True or false? Okay. 63. Now waves in the ultrasound range behave in the same manner as sound waves that are audible. And that is true. Right, okay. Behave, which mainly is okay, means okay, will be able to travel through the same mediums, so and so and so. Okay. Have waves frequencies which are inversely and reciprocal to the period. Wavelengths which are inversely proportional to the period of frequency, sorry. Okay. Likewise, power, amplitudes, and intensities. Okay. Or, as a matter of fact, it's going to be made up of, okay, as the for three acoustic variables: pressure, density, and particle motion. Okay. Compression, rarefaction, all those things. Okay, longitudinal, blah, blah, bleep, bleep, bloop, bloop. Okay, so a sound wave is a sound wave. Just like, okay, as a normal human being is a normal human being. It doesn't matter whether that person's name is Therese or Lillian, Christian or Christina. If you are normal human beings, that's okay, you'll behave in the same way. Okay, probably not, but that's okay, we are individuals. But it's okay, what will make you consider as okay, a normal human being is okay as you will follow the norms. Let's put it that way, right? Okay. Did that make sense? So a sound wave, whether it's a high frequency, low frequency, beep, beep, boop, 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 is going to just okay behave the same way. Sure. Did you guys get that?
Yes.
Good. So that makes it true. Okay, what characteristics of an acoustic wave? Okay, yes. Now, what are the characteristics of an acoustic wave? The frequencies exceeding 20,000 hertz when compared with traveling, okay, as compared with wave having frequencies less than 20,000 hertz. Okay, now they will travel more effectively in soft tissue. No. Clear? Okay, they travel more rapidly. No. Clear? Okay, they attenuate less. Okay, they attenuate less when traveling in soft tissue. Okay. Now that is also going to, that's wrong. Now why? Yes, okay, we will talk about that when we get to chapter number 6. Okay. Maybe actually you can say it's okay that a high frequency wave will attenuate more in soft tissues, but chapter 6. Okay. The human ears can't hear them. Yes. Clear? Okay. Because one is supersonic or ultrasonic. One is let's see. Okay. The human ears can't hear them. Yeah. Okay. Okay. So the one exceeding is okay, 20,000 hertz is ultrasonic. Where the other one, which is 20,000 hertz, that's okay, audible. So comparing these two, yes, okay, what's going to be, yes, okay, the feature that's going to, yes, okay, be different. And that's going to be that, okay, yes, the human ear can't hear the 20,000 ones. Okay. Or exceeding 20,000 compared to, yes, okay, what is less than 20,000. Yeah, okay. Did that make sense? Did that make sense?
Yes.
Good. Okay. So the frequency is not going to affect the speed that it travels in the soft tissue. So may I ask which of these two waves is going to be traveling fastest? More than 20,000 or less than 20,000 in soft tissue? We have two sound waves. one we can say as okay would be 19,000 hertz, one would be 20,000 hertz. Or let's say 21. So which of these two waves will travel fastest in soft tissue?
$21.
Okay, Caitlin, and why did you say that? What
Because
made you say 21?
it's a higher number. I was just
Okay.
thinking when we were doing
What were we doing?
the propagation, well, we were doing wavelength over frequency. I don't know.
Were we doing wavelength over frequency? Caitlin, you earned $1. You earned a bonus point. I would like that one back. My dear, in the topic where we talked about frequencies, right? Let me know. Let me be sure that's what I'm talking about. No. Wavelength, right? Was that the case? But that's what happens when you guys give me weird answers. But I even forget. Now, let me, oh, I need to, yes, okay, specifically, yes, okay, make me back to the page. And that's, okay. Here it is. Page number 36. Determined by second paragraph. Yes, Caitlin, what does it say?
Measured in units of meters per second.
No. Determined by. Page number 36.
Or all
Sorry.
sound, regardless of the frequency, travels at the same speed through any specific medium. Do you want me to keep going?
You can go on.
This means that the sound with a frequency of 5 megahertz and the sound with a frequency of 3 megahertz travel at the same propagation speed in the same medium.
Okay, what did I just do? I said that, okay, as you had two waves at different frequencies, right? Exceeding and less than 20,000, right? Hertz. But then I said, okay, what would be this propagation speeds in the medium? Or which one will have the fastest propagation speed? And you fell on it. Okay. You were trying to run so fast through the medium of soft tissue that you slipped. They will be the same. Clear? They will be the same. Did that make sense? Why would they be the same? Because it's going to be the nature of the medium that determines the speed, right? Clear? Okay. So is it two different tissues that receive sound wave with the same frequency? Then you will have to know that, okay, in which tissue does the speed travel faster and in which tissue does it travel slower, for instance, right? Okay. And that's why we had that list that we went over yesterday. lung, fat, soft tissue, liver, blood. What was else? Muscle, tendon, bone. Did you remember that? Where we went from slowest to fastest. So it will be the nature of the tissue and not the frequency, even not the wavelength of the sound wave. But the speed of the sound that will affect the wavelength. Clear? Okay. But frequency has no relation to the speed. Did that make sense, my dear? Okay, so next time I ask a question about frequency and speed, what will you say, my dear?
It'll be the same. They'll
Well,
travel.
okay, if they are not related, you can pretty much put it that way. Clear? Okay. They are not related. So changing one is not going to change the other. Clear? Okay, that's fine. Right now we're just in the beginning. So mistakes like these are still excused. Okay. Where are we now? Okay, good. Question number 65. Okay. What are the characteristics of an acoustic wave? The frequency less than 20 hertz when compared to frequency when compared with waves having frequency greater than more than 20 hertz. Well, okay, yes, the human ear cannot hear those lower than 20 hertz sound waves. Did you guys get that? Okay, yes, so less than 20 hertz, not audible. Yeah, okay, compared to yes, okay. Greater to 20 hertz. That's okay, that is audible. Question 65. No, not 65. 66. The frequency of a continuous acoustic wave. Okay, guys, don't worry about this question yet, because this is going to be okay. You will only be able to answer that once we are done. Chapter 4. Okay. So let's go to 67. And that's true and false. So is this statement here true or is it false? Okay. Now the period of an ultrasound wave related to the frequency is the same regardless whether that wave is pulse or continuous. Okay. again, yes, okay, chapter 4. Because you guys will not know, yes, okay, what it means to be a continuous wave versus being a pulsed wave. Yeah, okay. That's something that we will talk about or start talking about from chapter 4 and onwards. It will pop up again and again and again. Okay, guys? Okay, question number, okay, 69. This one here is a funny one. And let me put it. An important one too. What a number. Compared to sound waves. So we have wave A and we have wave B. Yeah, okay. Okay, guys. So although that's okay, yet you haven't seen, but it's okay. That's going to be, it's okay, a lot of questions which are going to be like this. Now, what they mainly say is that, okay, yes, because it's okay. One factor is going to be, it's okay, that we have frequencies. And what frequency is that they say is, okay, frequency of wave A is 1/3 of B. Yeah, okay. Which mainly is, okay, we'll just make the frequency of B 3 times of A. Did you guys get that?
Yeah.
Good. Now, what they mainly is, okay, just ask us is, how is the period of A compared to the period of B? Now, the period of A is going to be 3 times period of B. Now, let's just make it, okay, yes, very simple. And how we get that? You can see as, okay, we have E. Now, just to make it simple, guys, we can say, okay, if this here is 1 second. Likewise, as okay, for B, we say this one here is 1 second. Yeah, okay. Now, sound wave A has, let's put it this way. This is, okay, we can say it's okay. This one here has a frequency of 1 cycle per second. Whereas B has a frequency which is 3 cycles per second. So here's, okay, our frequency is 1 cycle per second. Here is going to be, it's okay, 3 times greater of A, which is 3 cycles per second. Did you guys get that?
Yeah.
Good. Okay. Where you can say as, okay, what is going to be the period here? Whether the period is going to, as, okay, be 1 second. Where what we see here is that the period is going to be, as, okay, be 1/3 of a second. Did you guys get that?
Yes.
Yeah, okay. Like, I mean, it says, okay, 1/3 or 1 is 3 times greater than 1/3. Yeah, okay. But if you say, well, okay, this was too obvious, well, okay, it doesn't matter. You can say, okay, that A, for instance, okay, had a frequency of 2 cycles. That B main is okay, just what how it's okay, well, it's twice or 3 times that, which will be, yes, okay. You can say, it's okay, 6 cycles. Which means, in that case, will mean, okay, as the period will have been 1/6 of a second. That here is okay, will have been half of a second. Where half is mean is okay, because going to be 3 times bigger than 1/6. Did you guys get that? Oh, yes, okay, if you understand the relationship between period and frequency, that would be obvious. Or whichever way you take it. Okay, question number 7. Dash is reciprocal of period. Now, who wants to answer this one here? Inverse period. No, okay. Have you ever heard of the word inverse period? No, so if you never heard of it, well, okay. It's probably never going to be done. It's not going to be the answer. That's one of the golden rules that I told one of my students. Okay. But that requires, okay, that you pay attention to yes, okay, word is being said. Because okay, you may see a thing and you say, like, I never heard of that. And I say, I'll be talking about this thing here from day one. If you haven't heard about it, then okay, as what the have you been doing? Okay. Pulse repetition period. Okay, guys, don't worry about that one yet. We'll talk about that in chapter number 4. Frequency is frequency reciprocal of the period.
Yes.
Frequency. Okay, good. So your period was
Time it takes to complete 1 cycle. Is that what you're looking for?
if the period was 1 millisecond. What will be your frequency? Kristen, you didn't say anything. Let the girls answer. If the period is 1 millisecond, what will be your frequency?
1,000 hertz?
Okay, what will be another way of saying yes? Okay, 1,000 hertz. Your answer is correct, but how will you say 1,000 hertz?
1 kilohertz.
1 kilohertz. Clear? So wherever I say that, okay, yes, the period is 1/10,000th of a second, what will be your frequency then?
You say that one more time.
If your period is 1/10,000th of a second, what will be your frequency then?
Ten kilohertz?
10 kilohertz, exactly, very good. Okay, how would you express 10 kilohertz using the unit megahertz?
.01 megahertz.
That would have been correct had it been 100 kilohertz. So you just need to add some more zeros behind the decimal.
From kilohertz to megahertz?
Yes. But we say 10 kilohertz, right? So that would be as okay, 100th of a megahertz, right? 100 of a megahertz would be 0.00 or 0.01 megahertz.
That's what she said, 0.01.
Oh, sorry. Okay. I missed the zero. Sorry.
You're
That's
messing me up over here.
Yeah, well, okay, my dear, my hearing is not what it used to be. Clear, okay? And especially as okay, you say zeros, I say zeros, that's worth nothing. So why should I even listen to it? Okay, dear. Okay, sorry, my mistake, Apologies. Yeah, okay. Is propagation speed reciprocal to period? Is propagation speed reciprocal to period?
No,
No,
they're unrelated.
they're unrelated. Hallelujah, you got that one right. Okay. Yeah. Good. Now, guys, since we didn't cover any new TOPICX, what will you be doing then? Okay, now we have from question 71 to 138. So some 62 questions, or 67 questions, right? Who are going to do those? Okay, now you guys can try to do them. Now, like honestly, don't look at the answer, don't look up the answers. Try to do them and see it's okay if you get your Answer is correct. Clear, okay. If not, just okay, you can mark it and say, Mike, okay, bum, 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 bum. These were the questions that can you show us how to do it? Because we are not having any idea of just, okay, how these here make sense. It's okay. Clear? Okay, so I can say that's okay tomorrow. I mean, it's okay, just be checking up the questions that, okay, that have been causing issues. And question that causes issues may, it's okay, cause you to use tissues. No, don't cry. Tears is not going to help, okay? Okay. Even if they run at the propagation speed of sound in bones. Okay. Okay, guys. So how is ultrasound physics going? Good? Okay. Somebody just look like, okay, as they sat on a hot iron or something. Okay. Okay, dear. No, it's just a big, and that's okay. A lot of things that we may just okay, just which may not make sense right now. It's okay. Hopefully, it's okay. At a later instance, will make sense. That's why it's okay. Okay, for two reasons. That's okay. That refer to future chapters. As we go further and further ahead in the book, I will say, okay, listen, guys, we already talked about this relation. This thing here is okay in a previous chapter. So yes, okay, guys. Once you're done with this fellow here, it's okay. You will have okay as a complete idea. Now, any last word of wisdom before I adjourn the class? So hopefully tomorrow is okay. We will go over the question that you guys had issues with. Okay. And after that, just okay. Hopefully it's okay. We'll be able to just okay start with chapter 4. And from here, it's okay. It's going to start looking more and more like ultrasound. So far, this was just general sound waves, right? Okay. Audible, inaudible. So, okay, guys. Tomorrow is Wednesday?
Thursday.
Oh, okay. Okay. That's fine. No problem. No worries. We are ahead of time. Our propagation speed is faster than the study guide. We are in bones. Okay, guys. Have fun. Enjoy your day. Okay, I just killed the enjoyment. You have some 60 plus questions to look at. But okay, yes, okay. If any issues, okay, just okay. Let me just skip it and okay, I will ask Mike tomorrow. Okay. Okay, guys. See you then.
Thank
All
you.
right, see you tomorrow.
Okay, bye-bye, guys.